All right, y'all. Today we're going to be talking about our different exponent properties, and we're going to start with our more basic of those exponent properties when we're dealing with more simple bases being multiplied together. So our first one we're going to talk about is what we call our product of like bases, and our product of like bases has to do with multiplying the same base with different exponents. So let's look at an example like number 1. We have 3x squared times 5x to the 7th. So when we're multiplying these numbers together, that 3 and the 5, they don't have an exponent on them, so I can just multiply those together. But let's go ahead and expand these and write this out before I just start multiplying. So that 3x squared is the same as 3 times x times x. And that 5x to the 7th is the same as 5 times 7x's. Now this is pretty tedious, but we can see we still have that 3 and that 5 multiplied, so we can multiply those together to make 15. And then counting up our x's, we have 2 x's in the front and 7 x's in the back, then that would give us x to the 9th. Now comparing this to our original 3x squared times 5x to the 7th, we can see that just like we thought, we did multiply 3 and 5, but our x squared and our x to the 7th became x to the 9th. So our x's, what changed about them is we took that power of 2 and that power of 7, and we actually added them together. Let's try this one more time and see if the same thing holds true, and if we can kind of draw some conclusions about it. So number 2, we have a squared times b times a cubed b to the 5th. So let's go ahead and expand this out. My first one would be a times b, and then our second piece would be 3a's times 5b's. So counting up our a's, we have 1, 2, 3, 4, 5. So that left us with a to the 5th. And counting up our b's, we have 1, 2, 3, 4, 5, 6. So that would leave us with b to the 6th. And comparing for our originals, keeping in mind that this b right here is the same as b to the 1st, we did do for our a's, because they have the same base, 2 plus 3, which gives us 5. And for our b's, because they have the same base, 1 plus 5, which gave us 6. So this leads us to our general conclusion, y'all, that when we multiply two bases that are the same, we can just add those powers together. So a and a, m and n, that base of a is the same, so we're just going to add those exponents m and n. So as an example, if we had x to the 5th times x to the 3rd, that would equal x to the 8th. So let's do a couple more and see if this still holds true. So we have x to the 3rd, y to the 6th, z to the 4th, times 4x squared, y cubed, z to the 6th. So this 4 is in the front, so I can just say 4, because I don't have any other constant to multiply it with. My x cubed and x squared would become x to the 5th. My y to the 6th, y to the 3rd would become y to the 7th, y to the 9th. And then my z to the 4th and z to the 6th, adding 4 and 6 together, would become z to the 10th. So a lot simpler than having to expand it out each and every time. Okay, let's look at one more together, and if you want to, you can pause and see if you can do this one on your own, or you can just go ahead and do it with me. So we have c to the 4th, 2 cubed, c squared, d to the 5th, and 2 to the 4th. So we want to look for those constants again, but we notice this time 2 and 2, they are the same base, and they both actually have exponents. So we can add those exponents together, and so this would become 2 to the 7th power. Then c to the 4th and c squared would give us c to the 6th. And then d to the 5th. We don't have any other d's, so it's just going to stay d to the 5th. From here, our c to the 6th, d to the 5th, that's going to stay the same, but we could actually evaluate 2 to the 7th. So if we wanted to use our calculator, because that one's pretty big to try and multiply on our own, 2 to the power of 7 equals 128. So that would give us 128 c to the 6th, d to the 5th. All right, let's explore another property. This is just our very first one, called our quotient property of like bases. So when I talk about a quotient, product has to do with multiplying, quotients has to do with dividing. And I'm going to skip number 5 for a second because I think it's going to be a little hard to show kind of our expansion of this. But let's look at number 6. We have 2 to the 5th, x to the 7th, over 2 to the 3rd, x to the 8th. And hopefully right away you notice that we're dividing this time instead of multiplying. But I'm going to go ahead, just like we did before with our products, and I'm going to expand this one out. So this would give us 2 times 2 times 2 times 2. So 5 2's, and then 7 x's. All over just 3 2's in the bottom. And this time 8 x's. Now looking across, we're doing division. And if we have the same thing in the top and the bottom of a fraction or in a division sign, we can cancel those out. So we can cancel out the 2's. And we can cancel out x's until all we have left is in the top 2 2's. So that would give us 2 squared. And the bottom, just a single x. Now, comparing that to our original one, you might see that 2 to the 5th over 2 cubed became 2 squared, and x to the 7th over x to the 8th became x to the 1st. So when we are doing our quotient property, we actually subtract the exponents. So products mean we add the exponents. Quotient means we subtract the exponents. So 2 to the 5th over 2 to the 3rd, 5 minus 3 becomes 2, so 2 squared. And x to the 7th over x to the 8th, 7 minus 8 becomes negative 1, which is why it ended up being 1 down here in the bottom. And just to finish this one off, 2 squared would be 4. So we could write this as 4 over x. Okay, let's apply this property to do some of our other quotient property questions. So x to the 19th over x to the 12th, that's the same base, and I can do 19 minus 12, which would give me x to the 7th. Okay, looking at number 7, we have z to the 4th, x to the 3rd, y to the 6th, over z to the 6th, y to the 6th. Okay, and then a 3 in the bottom. So I don't have anything to work with our 3, so our 3 is just going to stay in the bottom. Our z to the 4th and our z to the 6th, 4 minus 6 would be negative 2, so that 2 is going to stay down here in the bottom, so z squared. Then x cubed, I don't have anything to subtract it with, so it's going to stay up here in the top. And last but not least, y to the 6th over y to the 6th. That 6 and that 6, that would cancel out. So I actually don't need to account for that extra variable because it's just going to cancel out right there. So I'd just be left with x to the 3rd over 3z squared. Last but not least, we have number 8, 8a to the 5th, b to the 7th, over 12a to the 8th, b to the 4th. And something interesting about this, we haven't talked about this before, but that 8 over 12, notice that they are two different bases. So we are not going to subtract their exponents. We're just going to treat them like a normal fraction. So 8 over 12, if I was trying to reduce this, is the same as dividing both of these by 4. So it'd give me 2 over 3 as my constant in the front. So that's really important when you have a fraction, y'all, and they don't have exponents. We just treat them like any other fraction that you run into. Okay? Then our a to the 5th over a to the 8th, 5 minus 8 would be negative 3, so that a to the negative is going to end up down in the bottom. And then b to the 7th, b to the 4th, that would give us b to the 3. So that b to the 3 is going to end up in the top because our bigger exponent is on top. And that's really all there is to it, y'all. The last one that we're going to talk about, and we've already kind of seen it, is what we call our negative exponents. Okay, so our negative exponents occur when we have that a to some negative power. So like when we were talking over here, we kind of simplified it, but when we do z to the 4th over z to the 6th, we do get z to the negative 2. And when we do a to the 5th over a to the 8th, we do get a to the negative 3. And that negative exponent does something really interesting. Just like A negative usually flips the sign. Our negative is going to flip the fraction. So if we have a to a negative, it's going to become 1 over a to that same power but positive instead. And likewise, if we have a to a negative in the bottom of our fraction, then it would flip up to the top of our fraction and become a to a positive power. So on number 9, we have 2 over 3, x to the fourth over x squared, y to the negative fourth, y to the negative third, z to the negative third, and z to the fourth. And this time, let's move all of our negative exponents before we do any of our subtraction from our quotient property. So we're still going to end up with our 2 over 3. Our x to the fourth and x squared are going to stay in the same spot, but our y to the negative fourth and y to the negative third, those are going to switch places. Y to the negative third going to the top and becoming positive, and y to the fourth going to the bottom and becoming positive. And then last but not least, our z to the negative third and our z to the fourth. Our z to the fourth is going to stay down here in the bottom, but our z to the negative third is going to join it down here and become positive. Okay, now to finish this out, we can do our normal quotient property and product property if we have any. So we have 2 over 3, which I can't reduce that any smaller, so that's going to stay 2/3. Our x to the fourth over x squared, 4 minus 2 would be 2, so we're going to end up with x squared on the top. Our y to the third and our y to the fourth, 3 minus 4 would be negative 1, so we have y to the negative 1. And then in the bottom, we have z to the fourth and z to the third, both being multiplied in the bottom of our fraction, so we can actually add those exponents together. So z to the seventh. And we do have just one last thing. We have that y to the negative 1, which we really don't want to end up with that negative 1 in our final answer, so we can move that y back down to the bottom. So we get 2x squared over 3y z to the seventh. So as we start to kind of chain and put these properties together, y'all, it's really just about keeping in mind, if I'm multiplying, am I dividing? Do I need to add the exponents? Do I need to subtract the exponents? Do I have any negatives that I need to move? And that's really the biggest piece of it. It's just kind of keeping track of all those various things. So let's do one more together. Number 10, we have 3a to the negative 2, b to the fifth, c to the negative third, times 5a to the fourth, b to the negative first, c to the negative seventh. And everything's being multiplied. So let's go ahead and do our product property. So we have 3 and 5, which do not have power, so we can just go ahead and multiply them as 15. A to the negative 2 plus a to the fourth, negative 2 plus 4 would equal a to the second. B to the fifth and b to the negative first, adding those together would give us b to the fourth. And c to the negative third and c to the negative second, adding those together would give us c to the negative fifth. So we just got one last thing we got to do. We see that c to the negative fifth, which is going to move it down to the bottom of a fraction. So all of this is going to stay up in the top. And our c to the negative fifth would move down to the bottom. All right, y'all. Go ahead and try number 1 and number 2 by pausing the video. All you're deciding is you're looking at the 3 students and how they simplified and deciding which one of the 3 is correct. So for number 1, either A, B, or C, and number 2, either A, B, or C. So go ahead and pause me, and then try number 1 and number 2 on your own. All right, y'all, so hopefully on number 1, you got A. We have 3x squared times 4x to the third. That 3 and that 4, we would multiply to get 12 because they do not have powers on them. And then our x squared and our x cubed, they are being multiplied. So we can add those exponents together, x to the 2 plus 3, which would give us x to the fifth. And we can finally write our final answer as 12x to the fifth. B, it subtracts the exponents, and that's not good for multiplying. And C, it multiplies the exponents, which is not multiply. It's if we multiply, we add the exponents. All right, last but not least on number 2, hopefully you did pick B. We have that 36 over 4, which does become 9. And then our m to the 12th over m to the 4th, they are the same exponents being divided. So we subtract them. 12 minus 4 would give us 8. So we get 9m to the 8. A has us dividing the 2 exponents, which is no good. And C has us adding the exponents, which is not what we do for division. And y'all, that's really all there is to our basic exponent properties. Go ahead and try that Valentine's matching activity on the next page.